Is Earth truly unique? Or are we just one living world among billions scattered across the cosmos? For centuries, we've looked up and wondered. Now we are finding the answers. We've discovered planets where a year lasts mere days. Worlds potentially drowned under global oceans. Even a frozen super-Earth that might just cling onto the possibility of liquid water. How are we uncovering these breathtakingly strange alien worlds? And among the hundreds of billions of exoplanets in our galaxy alone, are we getting closer to finding another Earth? A true Earth 2.0? Join us on an extraordinary journey to the frontiers of space exploration. We'll visit some of the most bizarre and potentially habitable planets ever found. And stick around until the end, where we'll reveal the groundbreaking tool that promises to unlock the secrets of these alien atmospheres, perhaps changing everything we thought we knew about life in the universe. Let's dive in. Before we begin, support Beyond Earth by liking and subscribing. Thanks for exploring the universe with us. Only in our galaxy, there are over 100 billion planets outside our solar system. But over a long period of time, we never found an exoplanet that met the right conditions. So what's the problem? Initially, scientists mainly relied on indirect detection methods, rather than direct observations to find exoplanets. Since large gas giant planets are easier to detect, most of what they found were Jupiter-like giants. These planets, due to their extremely low moisture content in the atmosphere and lack of a solid surface, are hardly suitable for life. However, in recent years, astronomers have used new technology, leading to groundbreaking discoveries. One of the most effective methods is the transit method, formerly known as the zero-day method. This method relies on observing minor changes in a star's brightness to detect planets. When a planet passes between the star and the telescope, the star's luminosity briefly dips. The transit method has allowed scientists to successfully discover multiple smaller, Earth-like, potentially habitable planets. Among these planets, there are some breathtakingly strange worlds. Let's take a virtual tour of planets. Where there are only 2 days in a year, a water world with almost no land, and even twin planets very similar to Earth. First, let's explore a living planet. We arrive at a bright red star in the constellation Hydra, an alien system. Gliese 357, observed by the Transiting Exoplanet Survey satellite. 3 small exoplanets had been discovered here. Among them, GJ 357d is the farthest from the star. The energy it receives from this red dwarf star is similar to what Mars receives from the Sun. Scientists speculate that GJ 357d may lie within the star's habitable zone, although this depends largely on the star's specific temperature. GJ 357d orbits its star at a distance of about 30 million kilometers, with an orbital period of 56 days. This distance is only 1/5 of the distance from Earth to the Sun. Based on this distance, one might assume that GJ 357d's temperature is much higher than Mercury's. However, the opposite is true. Mercury, at approximately 58 million kilometers from the Sun, reaches daytime surface temperatures of up to 427 degrees Celsius, hot enough to melt metal, making it unsuitable for life. However, GJ 357d orbits a star 3 times lighter than the Sun, a red dwarf that is 40% cooler. According to astronomers' calculations, the surface temperature of GJ 357d is about -53 degrees Celsius. This is cold enough for the planet to resemble an ice hockey rink or a frozen wasteland. It was completely unfit for life. But scientists still classify it as a potentially habitable planet. The hope is that the planet's atmosphere is dense enough to trap heat and allow liquid water to exist. The presence of liquid water is one of the most important conditions for planetary habitability. After all, this planet could be a vast ocean or a rugged landmass covered in rock. Further investigation is needed. Researchers still need to determine the exact volume and composition of GJ357d. Fortunately, GJ357d's special location makes observations easier. It is only 31 light-years away from Earth. To put this into perspective, the distance from the Sun to Earth is only 1/100,000th of a light-year. On an interstellar scale, GJ357d is almost like our next-door neighbor. Currently, it is known that this planet has a mass about 6.1 times that of Earth. From this data, scientists speculate that GJ357d may have a rocky surface. If so, its diameter is about twice that of Earth. There is another possibility. The entire planet could be covered by a vast ocean. Astronomers are working to calculate the exact size of this potential water world. Now let's go deeper into space, to the constellation Volans, to visit a very intriguing planetary system. L9859, a planetary system surrounding a bright and cool red dwarf star about 35 light-years from Earth. The story began in 2019 when the transiting Exoplanet Survey satellite detected 3 planets orbiting this star. They were named L9859b, L9859c, and L9859d. These 3 planets orbit very closely together, as if hugging their star tightly. Specifically, their orbital distances are only 1/46th, 1/33rd, and 1/21st of the Earth-Sun distance. They are incredibly close to their star. Daylight on these planets lasts only a few minutes, and a year is equivalent to just 7 Earth days. The radii of L98 to 59, C and D, are about 0.8 to 1.6 times the size of Earth, respectively. A comparison image of these exoplanets and Earth, along with Mars, shows that they are roughly similar in size. Experts believe these planets are unlikely to be composed of ice or gas. In terms of chemical composition, they are more similar to Earth, with a lighter, less dense structure. Scientists have also measured the masses of these planets. One of them, L9859b, has a mass about 0.4 times that of Earth, with an error range of 0.15 times. This is about half the mass of Venus. Additionally, these planets have relatively low densities. L9859b has a density of about 2.1 to 5 grams per cubic centimeter. L98 to 59c has a density of about 3.7 to 5 grams per cubic centimeter. Earth's density is higher, partly because about 30% of its mass consists of a large iron core. In comparison, L9859b and L9859c have smaller iron cores, making up only 12% to 14% of their total mass. There is evidence suggesting that these 2 planets, L98 to 59b and c, are likely rocky planets, potentially even covered with vast oceans. In this planetary system, L9859d stands out as particularly unique. Its density is between 2.4 and 3.7 grams per cubic centimeter. Up to 30% of its mass may be water, far more than Earth, where water accounts for only 0.02% of total mass. That's a lot of water. It's unimaginable what kind of vast ocean could exist on this planet. In this planetary system, there's a 4th planet, once hidden from telescopes and out of sight. Later, astronomers announced that a 4th planet named L9859e has been discovered. Since it is not a transiting planet, its orbit does not cross the line of sight between its star and observers, so the original detection equipment failed to detect it. It is known that the mass of this planet is about 2.7 to 3 times that of the Earth, and its orbital period is 13 Earth days, apparently an extremely hot planet. In fact, the 4 planets in the L9859 planetary system, although they are all terrestrial planets, are extremely unsuitable for life. They're incredibly warm, comparable to Venus, although their parent star is a smaller and colder red dwarf than the Sun. But these planets are too close to their star, resulting in unbearable heat. However, scientists have also discovered that the system may have a fifth planet, according to speculation. The planet lies in the habitable zone, although only circumstantial evidence of it has been found so far. But if it does exist, its mass should be between 1.6 and 3.1 times that of the Earth. Although this planet orbits closer to its star with an orbital period of only 23 Earth days, in a red dwarf star system, such a distance is instead considered ideal. If the planet exists, the temperature may be moderate, not unbearably hot, and not freezing, which is conducive to the existence of liquid water. Scientists have also confirmed another fascinating object, Kepler 186f. This planet is in the Cygnus constellation, about 500 light-years from Earth. Kepler 186f orbits a red dwarf star, Kepler 186, with the other 4 planets together making up this planetary system. In 2014, the planet was discovered by scientists and is known as the Earth's twin planet, and for good reason. Kepler 186f is very similar in size to Earth. Its radius is only about 13% larger than that of the Earth. But here's the thing. This planet is also in the habitable zone of its star. It has the basic conditions to maintain the existence of liquid water. Although it is the farthest one in the planetary system, because the planetary system itself is small. Kepler 186f's distance to its parent star is only 60 million kilometers, equivalent to the distance between Mercury and the Sun. Fortunately, according to astronomers' calculations, this proximity did not make the planet become a hot sea of fire, due to its parent star being a red dwarf star much smaller than the Sun. Kepler 186f's orbital period is approximately 130 Earth days. Because red dwarfs emit less heat, the surface temperature of Kepler 186f is likely to be close to the level of the Earth. In addition, although red dwarfs are only 4% as luminous as the Sun, Kepler 186f is closer to its parent star. Therefore, the light received by its surface is about 32% of the Earth's. This means that if you stand on this planet, the brightness at noon is approximately equivalent to twilight on Earth, or the intensity of light in the Martian desert. However, despite having many conditions similar to those on Earth, the scientific community remains unconvinced by Kepler 186f. Whether it is truly livable is disputed. Red dwarfs in the early stages of their formation release a lot of high-energy ultraviolet light. These particles could destroy a planet's atmosphere, making it as dry and desolate as Mars. But scientists discovered a new finding in 2020 from researchers at the Georgia Institute of Technology, pointing out that Kepler 186f's tilt of the axis of rotation is similar to that of the Earth, and the change is small. The fluctuation range is between 22.1 degrees and 24.5 degrees, maximum every 10,000 years. This stable axial inclination helps planets maintain stable seasonal changes and ensure even distribution of heat and light. In comparison, the tilt of Mars' axis of rotation changes dramatically, can swing between 0 degrees and 60 degrees. It is this instability that could lead to the collapse of the Martian atmosphere and water evaporating from the surface. Although Kepler 186f is very similar to Earth in many ways, scientists are still unsure about its habitability. The planet's composition and density remain unknown. Whether it has an atmosphere is also a mystery. Regarding its mass, scientists speculate that if it were made entirely of water and ice, the mass could be only 0.32 times that of the Earth. If iron is the main component, the mass could reach 3.77 times that of the Earth. And if its composition is similar to that of the Earth, the mass is about 1.44 times that of the Earth. Currently, NASA has created an interactive stellar surface environment visual model based on relevant data for the L9859 planetary system and Kepler 186. Does it have the potential to give birth to life? It's still a mystery. With a new generation of space telescopes, in particular the launch of the James Webb Space Telescope, scientists are expected to uncover the mystery of these outer planets. Thank you for watching. Don't forget to like, share, and subscribe for more space adventures.